Okay, well done. Okay.
Good job, guys.
Now, I don't know if any of you know, but today is actually National High Five Day. So I thought we would quickly do one big virtual high five in the chat. But let's time it and let's all do it at once. Okay, so I'm going to count us down. Look for your high five emoji so long, if you can find it. It's just a hand is fine. I need to find mine as well. There we go. And I'm going to count us down, and let's all at once in the chat post a high five emoji. Okay, are you ready? I'm going to start. 3, 2, 1, go. Awesome. Okay, wonderful, grade 12s. Okay. I think we are ready for proving our identities. And before we do that, let's just do a quick refresh of our reduction formula. For those of you who have been around, I think most of you have been around for the last few lessons. We've been working our way through all the reduction formula and the rules around that. So this is just a quick refresh. I'm going to give you 3 minutes. Let's get started on this question. And when you're ready, when you've got an answer, put it in the chat. Okay, so our first question is up. It's a refresh of reduction formula, and I'm letting you give this a go on your own. In about 3 minutes, we're going to go through the answer. Anyone who's just joined us, welcome. You unfortunately missed the most amazing virtual high five ever, but that's okay. We can always do it again. Maybe at the end of the lesson. Okay, we've got some answers coming in already. Tan of x. Stay says it's tan of x, or Tilwe says tan of x. Mpo. Oh, there's Mpo. Number 2 on the quiz list. Well done. Okay, right. So I see you guys are on fire this evening, working through this very quickly. Okay, so we are going to reduce sine 180 minus x to sine of x. Cos 180 minus x. Cos in the second quadrant is negative, so negative cos x. We reduce it to that. Tan 180 plus x. 180 plus x is the third quadrant, and tan is positive in the third quadrant. Sine of minus x is minus sine x. Remember, sine of a negative angle is negative. And then cos 360 minus x is cos x. And then, yeah, we're going to cancel that. Those are all going to divide evenly, and we are left with a tan x. Well done. Good. I think we all warmed up and you guys are looking great with your reduction formula. So tonight we are going to start proving identities. So when we prove identities, we take the left-hand side and the right-hand side and prove that the one of the sides is equal to the other side. Okay. There's two important identities that we can use to do that. And the first one is sine squared plus cos squared is 1. And the other one is that sine over cos is tan. So sine of any angle over cos of that angle is equal to tan theta. Okay, so these are there for us to use to help us prove identities, but they are also identities in themselves. Okay, so anything that when you see sine over cos, you can change that to tan, and similarly you can change tan to sine over cos. Now, because of the sine squared plus cos squared equal to 1, we can rearrange this in a few ways so that we get cos squared by itself, and that gives me 1 minus sine squared x, or theta rather. And if I want to get sine squared by itself, then I can go sine squared is 1 minus cos squared. Okay, so those are the three versions basically of this identity. Okay, so let's jump right in and start with this one. Just going to give us more space. Okay, so when you do an identity, you look for the side that's a bit more complicated. So if we can write some notes here on how to do this, let's say our first step is to start with the more complex side. So if we look at this identity, it's obviously the left-hand side that is more complicated. So we write down left-hand side. So we're just going to work with the left-hand side, work it out, simplify it, and hopefully we are going to get to 2 sine theta. So cos theta, tan theta, plus sine theta. Okay, so my second sort of tip for doing identities is to always get everything in terms of sine and cos. So where there's a tan, replace it with our tan identity, which is this one here. So let's write a note here and say rewrite tan as sine x, cos x, or whatever the angle is, theta, alpha, but basically we get rid of those of the tan. So now we do sine theta over cos theta plus sine theta. Okay, now we can simplify this. So cos theta times sine theta divided by cos theta, that is going to divide equally. So we get sine theta plus sine theta, which is 2 sine theta. And that equals the right-hand side. Okay, so that's the nice thing about identities. You can always basically tell if you're getting it right, because you have to get the 2 sides equal. Okay, but notice that we don't work with both sides at the same time. We get the one side, simplify it so that it equals the other side. Okay, can I get a thumbs up if this is okay? I just want to see how everyone's doing with this, and if everyone's happy, got some thumbs up, please put it in the chat, or yes, put your thumb up. Wonderful. Okay, All good. Right, so let's then try this one. Question 2, wonderful, I get lots of thumbs up. That's great stuff. Okay, so let's then start with this question, question 2, and I'm going to give you a few minutes to work on it on your own, and then we'll have a look at it together. So off you go for about 3 minutes. Try this question. I'll scroll up a bit so that you can see your identities. Welcome to all the new people that have just joined us. We have just sort of entered the thick of proving identities. Great. When you've managed to get the two sides equal, pop a thumbs up in the chat, then we know that you got there. Okay, we've got 2 thumbs up already. Nice. Good stuff. Okay. Okay, let's have a look. So we're definitely going to start with the left-hand side because it's more complicated. It's more stuff, more sines and coses and tans on the side. And then tan x is sin x over cos x plus cos squared x. And cos x times sin x over cos x can cancel out. That leaves us with sin x times by sin x. So that is sin squared x plus cos squared x, which is equal to 1. And that is equal to the right-hand side. As you do these grade 12s, please pay attention to the layout of your work. So make sure that you indicate which side you've chosen to work with. So put your left-hand side there. It won't always be the left-hand side. Sometimes it is indeed actually the right-hand side. So put that there and then lay out your work as I'm doing here. Okay, let's have a look at question 3. I think in this case, we are also going to start with the left-hand side. So that's sin squared x over 1 minus sin x, cos x, sorry, not sin, cos. Okay, so we see a sine squared. Sine squared we can definitely replace with 1 minus cos squared. So let's go ahead and do that. Okay, now what can we do? Does anyone have any ideas? Put it in the chat or raise your hand. Okay, I see Temba. Do you know what to do from here? Give us some ideas.
Wouldn't we say, isn't 1 minus cos x equals sin x?
1 minus cos x equals sin x. No, it's only for the squared identity that we can do 1 minus sin squared x. Okay, in the chat, Site is saying factorize the top. I agree. What we've got at the top here is the difference of two squares. Okay, so difference of two squares and trinomials, all that stuff, all that factorizing applies to trig terms as well. So this will be 1 minus cos x, 1 plus cos x over 1 minus cos x. And now that we've made those brackets, now that we've factorized, we can cancel the 1 minus cos x at the top and the bottom. And then we're left with 1 plus cos x, and that is equal to the right-hand side. Well done, Tundalwetu. That is it. That is the factorizing. Excellent. Okay, so the next ones we are doing are starting to get a bit more complicated. But yeah, I think we're ready. We can do it. So let's have a look here at question 4. It might look like, or possibly I could work with the right-hand side, but I don't think it's really going to, there's not much we can do there. But on the left-hand side, we do see that there's a sine squared and a cos squared at the bottom. So we could potentially, I think we must go with the left-hand side. Okay, how about this one? Does anyone have any ideas here for this one? Put it in the chat or raise your hand. Who's got a hand up? Ukukhle, you can unmute and tell me what is your ideas.
We can change the cos squared theta to 1 minus sine theta. Sine squared theta.
Yes, I was thinking the same thing. And Neo is saying the numerator is a trinomial. Yes, well spotted. Okay, so factorizing, grade 12s, factorizing is very important when you're doing these identities. Okay, so Satya has given us the factorizing in the chat. It's they're saying sine x plus 1, sine x plus 1. I agree. But I also agree that we should change the cos squared to 1 minus sine squared, because then we'll only have sine in our identity, which makes it easier to work with because then everything's the same. Remember in maths, we try to get things to be the same because then we can work with them. Okay, so for my first step, I'm just going to do that. Sine squared theta plus 2 sine theta plus 1. Sometimes with these identities, maybe you thought, let me change the sine squared to 1 minus cos squared. Sometimes you do something and it doesn't work. Then just try something else. Okay. If it doesn't work, then just try something else, play around with it and see what can work to get you to the answer. Okay, so 1 minus sine squared theta. Okay, so we said that this numerator is a trinomial. Okay, and if you struggling to see it, I'm gonna write it as k squared plus 2k plus 1. Maybe that is easier to see than what it is with the sign. So sine theta plus 1 and sine theta plus 1 over. And I think we should definitely also be factorizing this again. That is also difference of two squares, 1 minus sine squared theta, difference of squares, so we can make that 1 minus sine theta, 1 plus sine theta. And every now and again, glance back. If you glance back to what we must get to, is 1 plus sine theta, 1 minus sine theta. We're close. We are gonna just need to cancel out, and then we're gonna do. Then we're gonna be there, which is always exciting. Okay, so here is sine theta plus 1. With 1 plus sine theta. Remember, those are the same. Sine theta plus 1, 1 plus sine theta, that's the same. Doesn't matter that the terms are the other way around. That is the same. And that leaves us with sine theta plus 1, which is the same as 1 plus sine theta, which is what we need in our answer. And then the 1 minus sine theta. And that equals the right-hand side. Okay, how are we doing, grade 12s? How's that? Do you want to put an emoji in the chat? Let me know how you are doing. Is everyone following? Oh, I'm getting hot. That's wonderful. Oh, and a party. Yay. Tandulita's rating it 8 out of 10. We've got some star eyes. Let's see some more emojis, grade 12s. I'm making it look very easy. No, you guys are doing this with me, so we are working together here. Well done, Stay. Some more emojis. Huawei Wi-Fi, maybe Miss Nicole, can you assist? There's a volume issue there. Unless, sorry, my voice isn't great this evening, so unless it's my voice that's not so clear this evening. Okay, wonderful. We are on a roll. We are on a roll. Let's keep going. Got some great positivity in the chat here, so let's keep going. Let's look at this one. Another challenge, another question, another challenge. So what have we done? Let's just recap what we've done so far. Okay, so we have gone with working with the more complex side. We've done that. Rewrite tan x as sin x over cos x. We've encountered some factorizing, trinomials and difference of two squares. And now we've got these fractions. So when we work with fractions, remember we need denominators to be the same. So the fraction ones do get a little bit tricky, but we're going to see how this unfolds. Okay. So let's have a look. Definitely, my bet is, again, to go with the left-hand side. The left-hand side is 1 over 1 minus sine theta. 1 over 1 plus sine theta. Okay, let me stop there. I almost just carried on. Okay, so let's make denominators the same. So our LCD here, can anyone think what the LCD is? Put it in the chat. Let me see if you can think what the LCD is.
Ma'am, the LCD is the 1 minus sine theta multiplied by 1 plus sine theta.
Good, thanks, Bonnie. Oh, my pen. Sorry, my pen is just stalling for a moment. Here we go. 1 minus sine theta and 1 plus sine theta. Okay. So to make the LCDs the same, we are going to times each term by what is missing. So 1 over 1 minus sine theta, we are going to times with 1 plus sine theta. And what I do at the bottom, I do at the top. So all those rules you learned back in grade 5 when you learned fractions, they are still in place. We're just doing it now with trig. Okay. And this term, to get the LCD to be 1 minus sine theta, 1 plus sine theta, we're going to multiply with what's missing, which is 1 minus sine theta. What I do at the bottom, I must do at the top. Not 1 plus, 1 minus. Okay, that leaves us with 1 plus sine theta plus 1 minus sine theta over 1 minus sine theta, 1 plus sine theta. Okay. Now, how are we going to get to the end? Look at where we need to go. We need 2 over cos squared theta. What can we do here? Any ideas? Put them in the chat.
Ma'am,
Yes, who am I talking to?
you're talking
Cool.
to Pepper.
Hi,
So
Tico.
I think in the numerator we've got 1 plus 1, and then which will give us 2, and then the sine theta will minus the sine theta, meaning sine theta cancels in the numerator. And then in the denominator we've got the difference of 2 squares, meaning we can write the denominator as 1 minus sine squared theta. So we are going to have 2 over 1 minus sine squared theta, which we can then simplify as 2 over cos squared theta, because 1 minus sine squared theta is an identity.
Wonderful. I think you should come teach the lesson. I can just sit back and let you do it. Wonderful, Tsepo. Thank you for that. Okay, so basically what we are doing, we are adding all the terms at the top. 1 plus 1 is 2. Sine theta minus sine theta is going to cancel. And 1 minus sine squared theta, remember from our identity, that is cos squared theta. So we can simplify that. 2 over cos squared theta, which is equal to the right-hand side. Yay! Great. Well done. Well done, everybody. Excellent. Okay, I'm just looking at the time. I think we've got time for, yeah, we should be able to finish these 2. I'm going to leave you alone with question 6 for a few minutes so that you can try that one on your own. I think you guys should be able to manage that one, the way everyone is just on fire this evening. Yes. Thanks for that, Mr. Cole. I'm glad you said that. If you don't, if at any point you feel that you're not sure, please pop it in the chat or put your hand up. We do have a hand up.
Ma'am, please scroll up a bit.
Scroll up. Okay.
Thank you.
Bluetooth mode.
As soon as you've proved the left-hand side equal to the right-hand side, put a thumbs up emoji in the chat. Has anyone got it yet? Everyone's gone very quiet suddenly. Ah, here we go. Okay, let's have a look. I only see one person with two people with a thumbs up. So let's remember one of the sort of golden rules or foolproof ways is to change the tan to sine over cos. This is tan squared, so we can change it to sine squared over cos squared. Okay, so we end up with sine squared x plus sine squared times sine squared here will give me sine to the power of 4x over cos squared. Okay, we need to make the denominators the same, which means my LCD is cos squared x. So I'm going to times the sine squared x by cos squared x over cos squared x. Let me write that out properly because there's not enough space. So sine squared x times by cos squared x over cos squared x. So we're just making the denominators the same. Excuse me. Okay, and then we've got sine squared x times cos squared x. So it's sine squared x cos squared x plus sine to the power of 4x over cos squared x. I can see now why maybe this took a while. It's taking a bit longer than I thought it would. So we take out sine squared x now as a common factor. And that gives me sine squared x cos squared x plus sine squared x over cos squared x. And cos squared plus sine squared is 1, which leaves me with sine squared x over cos squared x. And that is what we need to get tan squared x. So that's sine squared x over cos squared x is tan squared x. And that equals the right-hand side. Okay. So that's just using your squared identity and making the denominator the same the whole way through. Okay, we've got a hand. Okay, let's hear Iyazi. You can unmute and ask.
Ma'am, I don't understand. How did you get to sine to the power of 4x?
Okay, so the sine to the power of 4x comes from this second step here. I'll highlight it over here. We changed the tan squared x to sine squared over cos squared. Then sine squared times sine squared gives me sine to the power of 4.
Oh, okay, thank you.
Okay, no problem. Okay, any other questions before we move on to our other business? Kayla, yes, you can unmute and ask.
Ma'am, I'd just like to ask, where did the brackets disappear to?
So you mean the cos squared x plus sine squared x?
Yes.
So that is our identity, so that equals 1.
Oh, okay. Thank you.
Cos squared plus sine squared equals 1. Okay. Wonderful. Thanks for the questions, everyone. It is really good that you're asking questions. That's what this is all about. How much would this be out of? Okay, let's have a look. Changing tan squared x would be 1 mark. Then making the denominators the same, you could possibly get another mark for, or you will probably get a mark for sine to the power of 4x. Then making the denominator the same, that will be another mark. Factorizing will be another mark. Simplifying will be another mark. And that's it. So that's about 5 or 6, depending on how the paper is set. What level question is this? Yeah, probably level 3 around complex, definitely, because we've got lots of things going on. We've got the squared identity, we're factorizing, we're changing, so it's and we're making denominators the same, so it's definitely on level 3, complex procedures.
Ma'am, I wanted to ask for the brackets cos squared x plus sin squared x, isn't it removing the common common thingy, like the common factor, or is it like just turned into one as an identity?
Sorry, just repeat your question. I wasn't sure I understood.
For the second to last, the one where we have the brackets,
Yeah.
aren't we removing the common factors?
Yes.
Oh, okay. So it can be both removing. It can be seen as an identity and a common factor, removing a common factor.
Yeah. So we factorize this this part here. This is what we factorize. We take out a sine squared x as a common factor. And then because we factorize, what we get in the brackets is cos squared plus sine squared, which we know is 1.
Thank
I
you.
hope that makes sense. Great. Okay, right, everybody. We do need to move on. It is time for our quiz, but before we do the quiz, we are going to do a quick poll, please. Ms. Nicole, will you start the poll?